Well, now we talk about another very specific algebraic manipulation. We call it a consensus theorem, and which can become very useful time to time in the reduction process. And like if you see any kind of such expression, like it can may not be like directly two variables or three variables. It may be x is like another complex term and y is another complex term and z is another complex term. You can still do that. But anyway, in terms of simple terms, x, y, and z, it says x, y or x bar z or y, z equal x, y or x bar z, right? So what we are doing is here, like we are looking at that two variables, like y and z independent variable, are associating itself with complement and uncomplemented form of another variable, okay, in terms of and, right? So y is associating with x with and, so associating means here is, I'm trying to say it's an and operation. So y is anded with complemented variable x and z is anded with the same variable but complemented from, sorry, y is associated with uncomplemented form of x and z is associated with a complemented form of x, and then in the same expression we are ORing with these two variables y and z. If in such case we can drop straight this yz term and reduce directly to xy or x bar z, okay. So if this holds, then its dual also holds. So just we make left hand side right hand side dual and that holds. So now let's try to prove its original expression, like xy or x bar z or yz is indeed in fact xy or x bar z. So what we do from this left hand side expression, we make little expansion on yz. Yz is, we can write it as a yz or sorry yz and 1, right, by identity yz and 1, and 1 we can express as x or x bar. So that's what we are doing here. And in fact, just to note, in expression reduction process, just think also this possibility at some point of step a little expansion can lead you to more contraction. Means like for example here, like what we are trying to do, we are kind of, instead of reducing the expression from from the left hand side, as a first step we are kind of expanding it. First step and second step we are expanding the expression, but it will help in the long run because after that we can combine those terms in such a way it helps us to reduce. Okay, so this is in general. So don't always look for, okay, you have to strictly, you don't think that way, you have to strictly reduce in each step, like it has to be reduce, 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 reduce. It can go other way. It can be reduce, reduce, little bit expansion, expansion, and then reduce, reduce. It can go in that way too. But anyway, let's come back to this problem. So we write it yz as a xor x, yz and x or x bar. Then we are expanding this term in terms of xy, x bar z, xyz, and x bar yz. Then we are combining xy and xyz, and x bar z and x bar yz. We are combining them, and from there, with these basic identities and all this stuff, we can write down this term xy or xyz is basically xy and 1 or z, and then other term x bar z or x bar yz is nothing but x bar z and 1 plus y, 1 or y, then it becomes xy and 1 or x bar z and 1, and it becomes xy and x bar z. So see, now we have this left hand side is right hand side, and right hand side we just drop yz. So that's why this is a consensus theorem, and if you see any such pattern, you can reduce in one step. Just mention it is by consensus theorem. So that's all for this review lecture of Boolean algebra part, like it is mostly derived from Math 42, but in light of digital logic and digital logic design, digital circuit design perspective. If you have any question, please send me email or ask me in the class.